Welcome to Engineering Today. Today, we're digging into the fascinating world of geotechnical engineering and how new technologies are shaking things up, quite literally. The field is undergoing a major transformation, thanks to two powerful forces, metasensing and 3D modeling. These aren't just buzzwords. They're revolutionizing how we understand the ground beneath our feet and how we build everything from tunnels to skyscrapers. Let's first talk about metasensing. Imagine having a suite of super senses for the Earth. That's metasensing. It involves advanced sensors and data collection to give us unprecedented insights. For instance, satellite tech like InSAR can detect tiny ground movements over vast areas, crucial for landslide prediction. Then there are fiber optic sensors, incredibly sensitive and tough, perfect for monitoring stress and temperature inside structures. Ground penetrating radar, or GPR, lets us see underground without digging, mapping out soil types and hidden objects. LiDAR combined with drones creates super detailed 3D maps, especially useful in tricky terrains. And don't forget IoT-enabled sensors, constantly feeding us real-time data on things like soil moisture and structural movement. Underpinning all this data analysis are AI and machine learning, which help spot patterns and predict potential issues. Next up is 3D modeling. This technology is changing how engineers visualize and interact with subsurface data. Think of it as creating a detailed, interactive map of what's underground. These 3D models pull together data from boreholes, tests, and surveys to give a complete picture of site conditions, especially for complex projects. This improved understanding leads to better designs for foundations and tunnels. Engineers can use software to simulate how soil and structures interact under stress. Increasingly, these geotechnical 3D models are linked with building information modeling, or BIM, fostering better collaboration and leading to digital twins. These are virtual copies of real structures, updated with live sensor data, allowing for ongoing monitoring and predictive maintenance. Parametric modeling adds another layer, allowing designs to be quickly adjusted and tested. And, of course, these 3D models, sometimes paired with VR, are fantastic tools for explaining complex projects to everyone involved. The real magic happens when metasensing and 3D modeling work together. Metasensing provides the rich, continuous stream of data that feeds and updates these sophisticated 3D models. This powerful combination means more accurate risk assessments. Designs become more optimized and resilient because they're tailored to actual ground conditions. Construction becomes more efficient, and managing assets through their lifecycle is improved with proactive maintenance. This synergy also supports sustainable development by allowing for better material choices and construction methods. Of course, there are challenges. Managing the sheer volume of data, making different systems talk to each other, and finding skilled professionals are hurdles. But the trend is clear. Geotechnical engineering is becoming more data-driven, predictive, and holistic. Companies are using these tools to monitor critical infrastructure like dams and bridges, aiming for safer, more resilient structures for our future. And that's a solid foundation to build on. Thanks for tuning in to Engineering Today.